Hello everybody. So 4.5 properties of exponential functions. Okay, so this is a new function that we haven't talked about previously because we learned linear, quadratic, reciprocal, then we had absolute value, and what was the last one we did? And square root function. Okay, so now we're doing exponential function. It's a graph that you've seen before, maybe in other subjects, but the first time you're seeing it in math. Okay, so the equation is just this, y equals bx. So y equals b to the power of x. Okay, but instead of y, we use f at x now. Okay, and in the equation, b cannot be 0 because anything to the power 1 to the power of anything is just 1, so you don't get anything, you just get a straight line. Okay, so there's two types of equations that we can get. When b is greater than 1, we get one type of graph. And when b is in between 0 and 1, we get a different looking graph. Okay, so if it's greater than 1, we call this an increasing graph or a growth graph. Growth graph. Okay, so and the larger the number, the greater the increase. When we go from 0 to 1, we get a decreasing graph, or we call it decay. So we have growth and decay. And the smaller the number, the greater the decrease. So what the graph looks like, if it's on a Cartesian plane, in standard form it would go something like this. Okay, so it's exponential growth. Okay, you might have seen this in geography class before, where you're talking about world populations, maybe in a science class where you're talking about the growth of a bacteria population. So it goes this way. So that's an increasing graph. On the other side, a decreasing graph or a decay will go the opposite way. So it goes down like this. So this one's not the best example. So something like this. Okay, so we have an increasing. When we read it left to right, it's increasing graph. It's called growth. And when we read this one left to right, it is decreasing or a decay. Okay, so we use growth usually when we're talking about populations, population of people, populations of bacteria. Decay, we're usually talking about when something's breaking down. So often we talk about different substances that can break down. Okay, and when I think about decay, I often think about a compost where you start with something and it starts decaying. So if you put something in a composter, it starts off as a food, and eventually it decays into a soil, it breaks down. Okay, so first is asymptote. Okay, so each of these have an asymptote. So it's a point on the graph where the graph points, a line that a curve approaches but never touches. So here, when we're looking at the growth one, so this line's going to come very, very close to the x-axis, but it never touches. So we have an asymptote along this axis. Right? We touched on asymptotes when we were doing the reciprocal functions. So in the parent function, or in the very basic form, the asymptote is along the x-axis. But if we move it up or down, then the asymptote will change. Okay, also in the parent function, this graph always crosses here and here at positive 1. That is because when you plug a 0, so x is 0 into the equation here, anything to the power of 0 is 1. Okay, so I just want to put an example of growth. So this would be, say, f at x equals 2 to the power x, and this one would be f at x equals, I don't know, we could do 0.5 to the power of x. So this number is greater than 1, so it could be a 2, 3, 4, 5, all the way up to infinity. And this is a number between 0 and 1, so growth, decay. Okay, so just a recall from grade 9, you've learned about first differences. Okay, that's when you're subtracting the y values. So in grade 9, when you did first differences, if the first differences are equal, you used to have a linear function. Then in grade 10, you learned second differences. And if second differences were equal, then you'd had a quadratic function. Okay, so quadratic function. And now we're doing, so for exponential, what is, it's the ratios of the first differences. The ratios of the first differences, and we'll do with an example, then means it's an exponential function. Okay, on to the second page. Okay, so what we're going to do here is says graph the following equations. Is an increase or decrease, state the domain, range, y-intercept, and asymptote, and we are going to do the first ratios for each. Okay, so starting off, so our equation is y equals 2 to the power of x. So if you were to put a -2 into the power here, just to show you algebraically, 2 to the power 2, we have a negative exponent, so you would flip it. So it would be 1 over 2 to the power 2, which is 1 over 4. Okay, so our y value is 0.25. Okay, if you plug a -1 in here, you're going to get 0.5. If you plug 0 here, you get 1. And if I plug in 1, so 2 to the power 1 is 2, and then 2 to the power 2 is 4. Okay, so when you do the first differences in grade 9, what you do is you start with the y values. Okay, so we're starting with the bottom value, and what we're going to do is take the bottom value and subtract the number above it. So we do 4 minus 2. And then we take the 2 and we subtract the one above it, which is 1. So we do 2 minus 1. And then we continue that, 1 minus 0.5. And then 0.5 minus 0.25. So when we do that, you get 2, 1, 0.5, and 0.25. Okay, and then when we're doing the ratios, we do the same thing. So we're going to start from the bottom and divide. So ratio is when we're dividing. So what we're going to do is take the last y value and divide it by the one above it. Then we take that y value or that value and divide the one above it. And then we take that one and divide the one above it. So here we get 2 divided by 1. Then 1 divided by 0.5. And then we get 0.5 divided by 0.25. And when you do that, you get the answer of 2 for each of them. Okay, and since these are the same, we have a exponential function. Okay, and we'll do it to the same to the next one. Okay, plug in -2 here, this flips. So we get 2 to the power of 2, which is 4. We plug a -1 in here, we get 2. When you plug in 0, we get 1. Then 0.5 and 0.25. So you'll notice it's the opposite of the one we just did. Okay, so this goes from 0.25 to 4. This goes 0.25, sorry, from 4 to 0.25. Okay, first differences again. So 0.25 minus 0.5 is negative 0.25. 0.5 minus 1 is negative 0.5. Then we have -1 and then -2. So 0.25 subtract 0.5 is negative 0.25. 0.5 subtract 1 is negative 0.5. 1 minus 2 is -1. And 2 minus 4 is -2. Okay, now we do the ratios. We can only do the ratios after we do the first differences. So negative 0.25 divided by negative 0.5. Then negative 0.5 divided by -1. And then -1 divided by -2. And when you do that, you get 0.5 for all of them. So that's what it looks like so far in our lesson. Okay, so the first one was, so we kind of did it a little bit backwards. We kind of did the first ratios for each first. Okay, so this one, first question is increasing or decreasing. So we look at the number. If it's greater than 1, it is an increase. If it is between 0 and 1, then it is a decrease. So this one is above 1. So this one is an increasing graph. So it's increase. And this one's 0.5. So this is a decrease. Okay, but before we do this domain, range, y-intercept, and asymptote, we are going to graph it. Okay, so I'm going to graph them here. So -2 and 0.25, -1 and 0.5, 1, 0, sorry, 0, 1, 1 and 2, and 2 and 4. So we get a graph that looks like that. Now I'm going to graph the other one. So -2 and 4, -1 and 2, 0, 1. Connect the dots that way. Okay, so as you can see, from reading from left to right, we have an increasing graph. Reading left to right, we have a decreasing graph. Okay, so domain and range is next. Oops. Okay, so our domain, if this graph keeps going this way, so it gets all our negative values, and the graph keeps going this way. So we have all our positive x values, so it's just xer, and that is the same for both of them. Okay, now our range, you'll notice that our graph just keeps going along here. It keeps going closer and closer to the x-axis. So it keeps going in closer and closer to the x-axis, which is 0, but it never actually touches it. Okay, so it's all the values greater than 0. So it never touches 0, but it's everything above it. So we have very, very, very small numbers here, and our y values increase rapidly after this point. Okay, so we have y, er, but y is greater than 0. Okay, and that's going to be the same for this one. So it's all our, if this is continuous, it's going to keep hitting all our positive y values. Okay, as we read left to right, the y values get smaller and smaller and smaller, and they keep getting lower and lower and lower, and they come closer and closer to the x-axis, but they never actually touch the x-axis. And the x-axis is when y is 0. So it's everything above 0 once again. So YER such that y is greater than 0. Okay, it's not equal to because it never actually touches it, because there's an asymptote there, which gives us that point here. So where is the asymptote? So the asymptote is at y equals 0, because that's the point where the graph does not touch. And that would be the same for both of them. I'm just using SM as the short form. So y equals 0 is where the asymptote is. So that's along the x-axis. That's the asymptote. Okay, y-intercept. So I said previously that your y-intercept of the parent function is always here, so at 1. So y-intercept is where y equals 1. And I think we got them all. Okay, so we graphed them. We stated if it was increase or decrease. We did the domain range. We did the y-intercept, the asymptote, and we did the first ratios. Okay, so that is the lesson today. We will, in the next lesson, do transformations to the exponential function. So right now we're just looking at the parent functions. So this would be a increasing graph. Okay, this would be a decreasing graph. So we didn't put in any transformations to it. So this is what it looks like in its parent form. All right, homework got cut off on this page on my printout. So the homework is here. So page 241. So in page 241, I want you to do letters N and O. So 241, letters N and O. Okay, so it's just an explanation. And then page 243, you're doing number 1, which is you're doing first differences, second differences, or ratios to determine what type of function it is. So if it's the first difference is the same, it's linear. Second difference is the same, it is quadratic. If the first ratios are the same, then it is an exponential function. And then number 2, just ask you what type of graph it is. So it's just these questions here. Okay, there's end up being 8 of them. It's quite easy and quite fast, so you shouldn't have any issues with the homework. Okay, so again, page 241, N and O, and then page 243, 1 and 2. Take care.